In this video, we are going to solve International Advanced Level S1, January 2021. So let's begin with question number 1. Question 1 is, the Venn diagram shows the events A, B, and C and their associated probabilities. Here in the Venn diagram, set A, set B, and set C with their associated probabilities are shown. We have to find the probability of B complement. Now to find the probability of B complement mean outside the B. So what probabilities are outside the B? If I will consider outside the B, that is 0.15, 0.12, and 0.13. So it will be 0.15 plus 0.12 plus 0.13. So let's calculate them. Here we have 0.15 plus 0.12 plus 0.13. That is going to be 0.4. So probability of B complement is 0.4. In part B, we have to find the probability of A union C. Now, probability of A union C mean whatever is inside A and C and then their union. So that will include 0.15, 0.20, 0.23 and 0.12. So we will add all of these. 0.15 plus 0.20 plus 0.23 plus 0.12. So that will be equal to plus 0.20 plus 0.23 plus 0.12. So it will be 0.7. The probability of A union C is 0.7. In part C, we have to find probability of A given B complement. Now, as it is given B complement, so we will write the formula for probability of A given B complement. So it means I will write probability of B complement in the denominator, and it will be probability of A intersection B complement. Now, what is probability of A intersection B complement? Here we have to take the probability of A intersection B complement. So first, let's identify the region A intersection B complement. What is that one? So A mean inside the A. If I will take A inside the A, and B complement mean outside the B. So that region will be, if I will consider, if I have to, let's suppose shade A intersection B complement. So it will be like this one. I will shade inside of A. This is all inside of A. And then B complement mean outside the B. Outside the B, if I will take, it will be all outside the B, but we have to consider only the region when I will take. So outside the B will include all that region, including this one. So that will be the common region because we are taking intersection. So in intersection, we have to consider the common region. So it will be probability of A intersection B complement, it means it will be 0.15. Over probability of B complement, we already found in part A, so that is 0.4. We can write it 0.15 over 0.4. That will give us 0.375. Now, next question number 2. Here is question number 2. The stem and leaf diagram below shows the ages in years of the residents in a care home. This is stem and leaf diagram, and this is the key of the stem and leaf diagram, that if 4/3 is age of 43. So it means if you have to read this one, it will be 43, 54, 62, like that one. So find the median age of the residents. Now we need to find the median age of the resident. Median age means Q2. So how we will find Q2, the median age, it will be n over 2. N means from the total value we will divide by 2. That value will be the median value. Now, what is then the total number of values in this case? If we have to take, it will be 1, 2, 11, 22, 29, 31. So total number of values are 31. So I will do 31 over 2. That will be, if I will divide 31 with 2, so we will get 15.5. So 15.5th value will be, which there is no value 15.5, it means I can say I will round up, we'll say to the 16th value. So 16th value will be Q2. Now I have to check which value is 16th value. This is first, second, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this value is 16. So if I will write the full number with the, this is a stem and leaf diagram. So we have to write stem and leaf together. So it will be 74. So Q2 median, it means is 74. Part B is find the interquartile range of the ages of the residents. Now interquartile range means if we know interquartile range IQR is equal to Q3 minus Q1. So first we need to find Q3. Now Q3 is 3/4 of n, 3/4 of n. That value is the Q3. So if I will take 3/4 of 31, because total number of values are 31, so taking 3/4 of 31 will give me 23.25. So that I will round up to 24th value, 23.25, because not possible to take 23.25, so we always round up. So that will be 24th value. So which value is 24th value? I have to check here. This was 16, 17, 18, 19, 20, 21, 22, 23, and 24. So 24th value is 80. So I will write here Q3 equal to 80 minus Q1. Now Q1 is n over 4th value. If I will take its quarter, so n over 4th value. So 31 over 4. Let's take 31 over 4. If I will find 31 divided by 4, so will be 7.75th value. That we will round to 8th value. So where is the 8th value? 8th value is this 1, 2, 3, 4, 5, 6, 7, 8. So this 68 is the 8th value. That I will write 68. It means Q1 is 68. So our interquartile range will be 80 minus 68. So will give me 12. So 12 is our interquartile range. Now next for part C. Part C is an outlier is defined as a value that is either more than 1.5 times of interquartile range below the lower quartile or more than 1.5 times interquartile range above the upper quartile. So determine any outlier in this data. Show clearly any calculations that you use. So to find any outlier of the data, we know an outlier can be either greater than this value or it will be lower than this value. So what we need to do is we will first find the upper limit and lower limit. So finding the upper and lower limit to find the, let's say first I will take the upper limit. What is upper limit? Interquartile range can be more than this value Q3 plus 1.5 times interquartile range. Now we have Q3. Q3 is, we found already in previous parts, Q3 it is 80. So will be 80 plus 1.5 times interquartile range. Interquartile range is 12, we found in the last part. So if I will calculate this one, it will be 80 plus 1.5 times 12. That is going to be 90. So upper limit is 90. Now talking about the lower limit, Lower limit is always Q1 minus 1.5 time interquartile range. Now Q1 we found in the previous part, that was 68. So we'll take 68 minus 1.5 time interquartile range, which is 12. So let's find will be 68 minus 1.5 time 12, so which is 50. Let's calculate again. 68 minus 1.5 times 12. Yes, it is 50. So now, which one from them will be an outlier? We have to check in this data. Given data, do we have 98? So there is no value in this data. We don't have 98. So it means 98 cannot be an outlier. Any value less than 50 in the data, if any value is less than 50, so that will also be an outlier. So do we have any value less than 50? Yes, 43 is less than 50. So it means 43 will be an outlier. So therefore, outlier of the data will be 43. So I will say therefore 43 is an outlier of the data. Because 98 cannot be an outlier. Now in the next part is on the grids on page 5, draw a box plot to summarize these data. Now we have to draw the box plot. To draw the box plot, this grid is given here. What we need for the box plot, always we need the lowest value, least value other than an outlier. Because first of all, I will draw the outlier. We have an outlier 43. So if outlier is 43, first look at the scale of the grid. Scale of the grid is 10 boxes horizontally are equal to 10. So it means each box is equal to 1. So if I have to show 43, so it's 40, 41, 42, 43. So here I will say this is my outlier. So for outlier, we always put cross. Let me make it more clear. This will be a cross of the outlier. Now after this, we have to draw, we need the least value, we need least value other than an outlier, because we cannot take the outlier as the lowest value. So the least value in the given data other than an outlier, that is 54. This is the minimum value in the data. So 54 I will write, I have to make here. So this is 50, 51, 52, 53. So for 53, now it's up to you. You can make a box. Okay, let's see. I will take like this. It's your choice how long line you draw. This is for 54, the lowest value, and then after that, median of the data we found in the part 1, that was sorry, Q1. After that should be Q1. Q1 was 68. So I will draw here 68. 68 is, this is 65, 66, 67, and 68. So 68 is here. This is 68. Make sure the length of the lines that you draw should be equal. And then after that, this is Q1. Between Q1 and the least value, you should draw a straight line. And then box will be for Q1, Q2, and Q3. Q2 was 74. So that is 70, 71, 72, 73, 74. So here this will be. And then Q3. Q3 was 80. We found in the previous part Q3 is 80. So here I will make this box. After that, the highest value of the data other than an outlier. So highest value other than an outlier is 97. You can see from the given data, it is 97. So I will show here 97. This is 91, 95, 96, 97. So here we have. So we completed our whisker, box, or box plot. You can write these values also if you want, otherwise here this second question is also done.